Hi everyone, how you doing? We have a special guest today, David Korshid. We're going to have a code conversation on XState. The first thing we're going to talk about is what is XState?
XState is a library of JavaScript and TypeScript for creating state machines and state charts. While there's like a million state management libraries, XState is that state orchestration library.
It uses state machines to represent the flow of data over time. It says that a function or a module or a machine or a component can only be in one state at a time.
Yeah, what I mean by that, or at least what, literature says about finite state machines is that this restriction of you can only be in one state at a time, which is like the cornerstone of what makes a finite state machine, is more about the behaviors of the apps. The finite states, at least in terms of UI or applications, it represents the behavior. Let's say that you and I were finite state machines. We behave differently when we're asleep and when we're awake. But obviously, we can't be both asleep and awake at the same time. When something happens, we react to it differently. Obviously, we might react to something differently when we're asleep than when we're awake. And so that's why those are two separate, mutually exclusive behaviors. That's why they constitute different finite states. We see these in our applications as well.
Let's take a look at XState and how it looks like for somebody to use it.
This is a very basic XState React template. And if you go to github.com/statelyai/xstate, you're going to see a bunch of templates over here. So if you want to use React or Vue or Svelte or TypeScript or whatever you want, then there's a lot of ready-made templates where you could go into Code Sandbox and just start playing with XState from the very beginning. Everything in XState really revolves around this idea of creating a state machine. And in XState, you create it in this object sort of form. In XState, you have your finite states. So in this example, it's a very trivial example, but whenever you click, it toggles it on and off. And whenever it's toggled on, the count increases over there. So it's like a little bit more advanced than your typical counter example, but it also shows like a typical toggle where you have inactive and active. Honestly, this example isn't very interesting. One of the best examples of like where you would use a state machine is for wizard forms. So in a wizard form, you have a certain number of different states or steps.
You're not recommending necessarily using XState on everything in your application where you could do it, but you're recommending it more where it makes a lot of sense, where you have many different states that all have dependencies, and you want to make sure that you're able to go forward and backward in those states and keep track of them. And XState can handle it.
Yeah. So XState can stand alone as a state management tool. However, it's best suited for more complex applications and needing to deal with coordination between different states. A state machine is like the brain of whatever entity you decide to put that brain in. And you could have many entities. So over there alone is a big difference from Redux, where Redux, you have a single brain. That's your global store, and everything goes through there. It might be a conglomerate of many different reducers in that global store, but still it's a single global store. If you want to do anything that's not global state, then that's something separate, and you have to find some way to manage that while Redux manages the global state. With XState, everything is local first, but all of these local parts can talk to each other if you wanted to. So I'm just going to pull up a quick example over here. What's a fun one? Oh, okay. I like this one. I have a timer on my phone. I use an Android phone, and the timer looks like this. This is just a minutes timer where you have a bunch of features over here. You could play and it's going to count down from 5. You could pause it, you could reset it. While it's playing and while the timer is going, you could add a minute and you could see it goes to a minute. You could press here to pause. You could reset it, press here to play, press here to pause. So you see there's many different places where you could actually do the same thing. This is a good example of what a finite state machine is used for. You could see the finite states at the top over here. For example, paused, running.normal. And the reason it says running.normal is because if you let it go past the time, it goes to running.overtime. So it's still running, it's still counting down, but now it's in a different child state, which is that running.overtime. And sorry, but this is like just a deep dive into, here's a good example of a really complex, or at least a moderately complex application in which you would have a really good use case for a machine. And what was I going to say? Typically, when you're doing this in React or something, you would think, okay, I have a few variables to keep track of. I have to keep track of is playing, is paused, is overtime. And I also have to keep track of the total duration and the interval and how much time has elapsed. So each one of those are use states. But over here, it's different is pretty much all you need.
Oh, so you're saying before with React, if you wanted to build this yourself, one, you're working with a lot of asynchronous state changes. And in those asynchronous state changes, you're going to have multiple use state hooks to represent that same amount of state that XState is doing for you in one single use machine hook.
Exactly. So while I fix the errors over here, yeah, it's use reducer in a way where with use reducer, it's a step up from use states because in use reducer, you could represent, it's actually better than use state for two reasons. First of all, you could represent a lot of state in use reducer. And just you're used to doing in Redux or something similar, you could just granularly update parts of the states that only needs to be updated. And the second thing is that changes are represented using events. So the only way you could change the state is if the reducer receives an event. They call it action in the docs, but in XState, those are events. When you receive an event, you do something with the events, you change the states, but there is something missing because even if you do use reducer in this timer app, for instance, you still have to figure out how to actually run this side effect. These side effects are really important. You have complex orchestration of this because you have the timer that's running, but it should only be running in this running state. And if you stop it, then it should not be running, ideally. I guess if it does, then it doesn't really matter. In more performance sensitive places, you really don't want it to be running. And so you do want to control that timer too. That's why with XState, finite states, events, and transitions and side effects are all first-class citizens in the library. If we jump into the code and I show you what this actually looks like, this is from a while ago and it's also in TypeScript. Sorry about that. Don't want to scare people. But yeah, this is our data. So we have duration. And I'll zoom in a bit here. We have duration, elapse, and interval. This is our non-finite, or you could think of it as our infinite or quantitative data. So this data is just random, or not random, but it's data that doesn't really signify what behavior we're in. Now, the behaviors that we can be in, we could be in an idle state where we're not running, the machine is stopped. We could be in a running state, or we could be in a paused state. And so you could imagine just by looking at this, that when you're in the idle state and you press play, you're going to go to running. When you're in the running state and you press pause, you're going to go to pause and then you go back to running. And if you click reset, then you should just go back to idle. This is the type of thing that you would probably want to diagram up, but XState makes it so that you could pretty much diagram it in code. And you could say on toggle that button, go to the running state. And so in the running states, now we're doing a few things. We're running this ticker as a side effect. Whenever we get a tick, we're going to increment the counter over there. When the toggle event happens, now we go to paused. In the pause state, we go to running. It's represented pretty succinctly in this object like that. In my opinion, this makes it a lot easier to understand what's going on. Not this necessarily, but just the idea of you design it using a finite state machine, and then you apply it to your application. And it's all in just one little hook. All of the logic is contained in there. So that's a deep dive into using XState in a React application.
One of the things I want to look at is because all of this finite state machine is inside of an object, that means it allows for static analysis. Using that static analysis, you can actually visually see that diagram you were talking about.
Yeah, exactly. With the static analysis, like even here without running the code, the extension called XState VS Code. So if you look up XState VS Code, then it's something that one of our team members, Matt Pocock, created. And it's really awesome because if you're in VS Code, a little inspect machine will show up here in this create machine, and you can actually visualize the machine running. And so actually, I could probably demonstrate this for you over here. Let's add some dependencies.
Oh, so we're going to do this live.
Yeah. And in fact, I haven't tried it on this one. So we're going to see how well it works, but I'm going to install something called XState inspect. And we're going to import inspect from XState inspect. And then we're just going to inspect, and I want to do it in a separate window because I don't have an iframe set up. So I'm just going to do iframe false over here. And then the last thing we have to do, so we don't get an explosion of things we don't want. This is yelling at me that this should be up here. Is set dev tools. It's true. Just for this machine. What's going to happen, hopefully, is that when I save this, another window is going to open up, and you could see right here, this basically shows our state machine. So we have the idle states, and we could see when you click toggle, it goes to the running states. And then a few things can happen. You could go between normal and overtime. So whenever the timer expires, then it goes to overtime. And if you reset, then it just changes the amount there, but you could pause. Then when you toggle, you go back to running. So you could take this and you could show another developer, a designer, or project manager, and just be like, hey, this is the current logic of our application. And this is basically how it works.
I like that we're able to show the diagram and document the code that was written just in a single object. As far as I know, that window that opened up is also able to be interacted with.
Exactly. And actually,
That was cool. I didn't know you could do that.
yeah, so we just released a new visualizer. And so this visualizer is also going to work pretty much the same way. Hopefully. Yep. There we go.
Oh, so this visualizer is connected to the running timer in that code sandbox right now?
It is. Yeah. And so if we were to play here, you could see that we're in the running state, and eventually it's going to go to the idle state after 5 seconds. Oh, okay. Now we're in overtime. So you see it's in overtime over here. And so we could click reset over here, and actually it's also bidirectional. So if I click toggle right over here,
Oh, it starts a timer.
it starts it over here. So I could pause it, toggle it again, and it's running again. I haven't set it up in here, but you could definitely also embed this directly inside of here. So you could have a visualization over here. And we're also working on browser extensions and things like that. So you don't have to like just go back and forth between two windows to do that.
That's incredible. I did not know it had gone to this extent. So I knew there was a visualizer. I knew you could interact with the visualizer. I didn't know the visualizer would run against your actual code. And I didn't know that you had a bidirectional dev tools for XState. This makes me want to use it right now. It's so good.
Yeah, if you think of XState as just a glorified state manager, then it works just like that. And there's really very little learning curve. You have your context, which is the data that you could edit. And then you have on, which is sort of a container for your events. And so whenever an event comes in, then you could just change the data if you want. And so you could treat XState that way, but actually learning what finite state machines and state charts are, honestly, it's something that every app has to some extent. If you are creating anything that goes beyond just a create, read, update, delete app, like a normal CRUD app, or even with CRUD apps itself, there's definitely use cases where there are hidden state machines inside your application. And all XState is doing is exposing it so that you can know all the features that happen in your app. You can know how state is going to change over time. You can know all of the capabilities of your app, like what users can do, what events can come in, and what events are going to change the states. And so it basically gives you a bird's eye view of the entire application logic in a way that plain code really can't. And I know I'm really trying to sell XState hard, but that's the idea behind why you would want to use state machines and state charts. The main reason is to get a better understanding of your code.
There are a few things I'm seeing that XState is offering. One is documentation. Because it's statically analyzable, it does provide documentation. Another is DevTools. It allows you to debug your application a lot easier. If there's something not working correctly, you have two ways of now seeing it. One is through the application, but the other is also through a visualization of that. The last thing I'm thinking is that XState also makes it easier to make reactive designs when you have multiple states that you're working with. I want to know other examples where you have seen XState used or you use XState yourself, where somebody would be thinking about it in the sense that, okay, it's probably too complex for this modal state to go open and close. That's pretty simple. But if I really needed to use XState, where would I want to start doing that?
I would say anytime you have a wizard form, for sure, anytime you have any sort of multi-step process, a lot of people are using, especially in the React world, tools like React Query for just fetching data, but sometimes you have to orchestrate like when that data gets fetched. And even simple use cases like, let's say that you want to load data. And so you type in the search term, you're loading data, and you decide, you know what, I actually don't want that data anymore. I'm invalidating that. I'm typing something new. Something needs to actually say, hey, we're going to cancel that request and we're going to just refetch and do another request. So Even a small amount of coordination like that would elicit a state machine where you could say, okay, there are certain states that the user can be in when they're making those requests. And another I've seen is when you have to actually chain requests, where it's like fetch data, then fetch other data based on that data. And we're not talking GraphQL, we're talking like in actual chaining. And also like then wait for user inputs and then fetch more data and then do something else. So that's another use case.
For that situation where you're trying to orchestrate all those fetch calls, the reason you would do it in XState is because you might have to retry, or it's able to handle the fail states.
Exactly. Yeah. Yeah. When you want to do things like retrying or cancellation or things like that, then there's really no easy way to do it without using some sort of state orchestration. That's where something like XState comes in. You could pull down like a black box solution from NPM that sort of says, okay, we'll handle retrying for you. But if you do want that granular control, then that's when you would do something like XState. It could seem a bit daunting. Oh, XState has all of these different concepts, but it really boils down to three things: states, transitions, and events. Anything that can happen is an event. Behavior is represented in the states. And events can cause changes in behavior. You could think of each of those behaviors like a reducer in a way.
When you had the action before and it said toggle, and that was an on, so there was a keyword on. When you have an on, that is essentially dispatching an action in Redux that is then being handled by a reducer, but that reducer could be then another thing that is dispatching another action, or it could be changing the state and then also dispatching an action at the same time. Essentially, what I'm seeing from XState is what I got with redux-observable, or what some other people are used to with Redux sagas. It is the event-driven part of Redux. So Redux is actually two things. It's a state manager and an event-driven piece. The event-driven thing is actually Redux. The state management piece is a side effect of Redux. So with XState, what you're doing is you're building the same functionality you would have gotten from Redux, but you're building it into a single hook through this statically analyzable method. You're passing this in, and then it's allowing you to change the state and manage how those states are all interacting with each other. But you also get a visual diagram of how that's happening. Something I wanted to also note is that XState is not specific to React. There's a hook that allows it to be used with React, but XState could be used anywhere, even in Node.js applications.
Yeah, and that's definitely one of the biggest reasons that I worked on React and made it like framework agnostic, is that it really represents a definition of your application logic that is portable. It could be used anywhere. We have small adapters for Vue, React, Svelte. What's funny is there's actually no XState Angular, and that's because number one, I'm not that experienced with Angular. Number two, an interpreted XState service, so like the thing that's actually running, is observable. So if you want to use it in Angular, you just use the from function from args.js, like from service, and you're done. That's all you need to. You just
that's nice.
Send events to that. Yeah. So it actually works pretty naturally in Angular, which is pretty nice. And so we're also like playing around with XState for Python. And that's another thing to mention too, is that all of this is actually based on a W3 spec called SCXML. But you can imagine that devs don't really want to write XML nowadays, even though they're all writing JSX, which is pretty much the same thing. Anyway, so this SCXML spec dates back to, it was published in 2015. And it like just the way you would build state charts, and it has all these algorithms. XState tries to follow that closely. And because we follow it, we could port that to different languages that also implement the same algorithms. And I think that's going to be very useful in the future.
What I'm seeing here is then you could create JSON of your XState, and then you can port it to different languages without having to translate any of the code.
Exactly. And honestly, it's a bit of a turnoff for a lot of developers to see, oh, this is a huge JSON object that I have to edit. Can you at least give me YAML or something? Actually, no.
It doesn't have to be JSON. Right now, it's just JavaScript.
It is just JavaScript, but like it's a very much object deal. You have plain old JavaScript objects in there. But there's a couple reasons for that. One of them is when you mentioned the static analysis part, and the fact that you could take it and you could visualize it. And the second part is that it's an authoring medium. So we're working on a visual editor where you could basically drag and drop these nodes in visual editors, and they work best with some sort of declarative data format like JSON. And so it renders JSON. You could use it directly in your applications. So now you have an editor that not only lets you make pretty diagrams, which you would probably use Excalidraw or Draw.io or Lucidcharts for. It not only does that, but you could actually use those diagrams as code, which is a really interesting concept that I'm super excited for.
Oh, I see it now. You can literally drag and drop boxes in.
Mm-hmm. Yeah.
and show how the state works. So anybody in the business, anybody could do that. And then
Yes.
now you can write the code underneath it for what happens in those states.
Exactly. Yeah.
Wow. Wow.
Yeah. So you could fill in the blanks because a lot of our applications, like it's basically the same ingredients for a recipe, so to speak. I don't know why I thought of this analogy, but if you have like dry ingredients, wet ingredients, water, oil, whatever, you're adding your own personal touch to it at the end. So that personal touch is your implementation details. Every application has these finite states. They have the user can do this or that or that. And the application, we have this page or this mode or that mode. Those are all states. What the user can do and what comes in, those are all events. So these are the same building blocks. The only thing that's really different between applications is the implementation details. What libraries you're using to make fetch requests and side effects, what framework you're using to render, even what language you're using. Those are just implementation details. And the hard part is the actual design and the modeling of it. And so that's what we want to tackle.
The design and modeling of a system that lets you build all of essentially the diagram or the schema for what you're working with, and then allows somebody to implement it after the fact.
Exactly. So if you're working on an app, you want to say like, all right, we're going to have a login page. And if the user presses login and their user credentials are correct, now they end up in the dashboard. So the way you describe that, if you were talking to a designer or project manager, you would not describe it in code, or at least hopefully not. You would either use user stories, which is plain English, hopefully they all understand it, or you would use diagrams. Or ideally, that's the communication mechanism with your entire team and even with other developers. But the way that we code things now, it's all in code. We have these user stories, I think, from a while ago, but they might be out of date because the code does something different, and these diagrams are also out of date. That's a huge problem that we want to solve.
I can see multiple use cases here. For instance, you could use XState to model a diagram prior to putting it in your application. It's a lot easier if it had that capability today. It would be a lot easier than doing it with something like Lucidchart, where you got to do all that yourself. Then there's the other piece that you're talking about is a living documentation. And then by taking that documentation or that diagram and putting it into your code, now it lives with your code. And if you need to remake a diagram, you just copy that into the Stately visualizer, and it creates the new visualization with the code as it is today. But what's really going on is there's this state machine that you've created. That state machine holds all of the logic of what is supposed to happen in different states. And then the code behind it is only written within the confines of the machine. It's not just random code out there that can run and do whatever it wants at any point in time.
Exactly. Yeah. These constraints, we find really useful when developing applications because they force developers to think about, okay, what are all the different modes that my application can be in, or states? And yeah, it forces like your entire team to basically speak the same language, or at least all of your developers. And so we find that really helpful.
Yeah, I'd love to see a whole project that uses XState and to see how it looks from that perspective and how it looks from those users' perspective.
Yeah, honestly, there's a lot of projects that do use XState. In fact, if you go to stately.ai/viz, the entire visualizer uses XState itself. We also really like Cypress.io has a real world application, and this application has state machines all over the place. We really like it because Cypress intentionally built a very real world app, both for demonstrating the capabilities of their testing platform, but also for demonstrating how you could just use state machines in a variety of situations. There's also XState-catalog, the British spelling of catalog.com. And that demonstrates a bunch of just different examples of state machines.
Real world app built by Cypress. Okay. And then this uses XState internally. Okay. Interesting. I'll have to check this out at some point. And what was the other thing you said?
It's called XState Catalog. So if you go to XState-catalog, UE, like that British spelling.com, then it shows a bunch of examples of XState that you could actually copy and paste into your very own projects.
Okay, so this is the other benefit of XState is that people can write the state machines ahead of time. You can share those and they're going to be the same for every application.
Yeah, or mostly the same. And so what we envision is with a registry, which you could save and share state machines in. If someone wants like a specific type of state machine, let's say they're creating an application that uses drag and drop, you could try to find a library that does exactly the kind of drag and drop you want in the framework that you want, or you could just copy and paste a state machine for drag and drop and say, I actually have some custom logic, and just go ahead and modify that logic in the state machine and then just use the state machine. So we're really removing the black box parts of logic and packaging up logic and really getting it over to the developers to do whatever they want.
I also noticed that there are multiple state machines in a machine. Is that something where you have multiple, essentially finite states within a single machine?
Yeah. One feature, it's called statecharts, and it's nesting or hierarchy. Basically, you could say, just like we saw in our timer example, you could say that we're in this state, but we're also in this child state of that state. Taking or going back to our asleep or awake example, I could be awake and hungry, or I could be awake and full. So I could be, it's not like just having multiple states. It's like hungry is a substate or a child state of awake. Or I guess you could be asleep and hungry too, but let's pretend that you can't.
Yeah.
And so that's just a way of organizing finite states. It's very possible to just make a very flat finite state machine. But the problem with that is you get a state explosion where you have just so many different states you have to represent. And just like you would group things into functions and do try in programming, you would also group related states into parent states. And that's just an organization technique that reduces the clutter and makes your application logic more organized.
Yeah. The last question I would have is, if we could see the code that you have for Stately, you said it uses XState. I'd like to see the implementations in Stately that XState's using to see how it actually looks like in a production app.
Sure. All right. So I'm going to go to the biz. This is open source, so ignore that. So you can go ahead and take a look at this. If you go to stately.ai/xstatebiz on GitHub, then you could see that if we go to our source, we keep everything pretty flat. We like that organization, but we go to, there's a whole bunch of machines over here. We have a notification machine, palette machine, simulation machine. And so this, again, it's a little scary. It's using TypeScript all over the place. But one good thing about using XState and state machines is that it doesn't matter if you come to a project years later, none of this is going to be fundamentally different. It's all still states, events, and transitions. We have a bunch of states. We're either inspecting. Okay, makes sense. We could be inspecting an application. We're in the visualizing states. And there's a whole bunch of events that can happen. So I'm just going to scroll down here. Okay, so we could see that there's a layout.pending event, and that's just an internal signal that, okay, the layout's pending. That makes sense to me. There's also machines.register, in which we would say, okay, we have a new machine coming in, machines.reset, and just set it to back to its normal state. And so you could just see which events can happen when. And we don't have code folding over here, but you can imagine that if you want to see a bird's eye view of all the events that happen within a state, then it's all over there. We see, okay, here's what happens when we get the service.send event and service.register, etc. You get a really good preview of just all the different features in your application. So I could see here, we could focus on the service, preview an event, clear a preview. And of course, all of this is visualizable too.
I'm curious, can we take this code and see a visualization of it right now?
If you're creating a machine in isolation and you're not doing it within an application, if you're doing it within an application, then yeah, you could run the inspector and see the machine live because you don't have to worry about imports or anything like that. But otherwise, yeah, you have to figure that out.
Oh, I see. I really appreciate talking to you about XState and how it works and how the functionality works altogether. It seems like there's a lot of opportunity here for people to then better document their projects and then show those flowcharts that you'd normally have to write by hand that don't stay one-to-one with the code.
Exactly. Yeah. Our goal is to solve the whole code to diagram communication problem.
Thanks so much, David.
Yeah. Thanks for having me.